Hi friends, Marin with Into Mobile. We're at Nokia's Research Center in Sunnyvale, and we're going to take a look at their high accuracy indoor positioning. So it's a concept right now, but it's not that far away. This is Fabio with Nokia, and he's going to tell us all about it.
Right. So what we did at Nokia, we took standard Bluetooth Low Energy, which is also called Bluetooth 4.0, and we developed on top of that a new protocol layer. This protocol layer, which is currently under standardization, will allow it to use Bluetooth Low Energy signal and to compute directions. If you now can compute direction, as we see in this demo, you can place what we call locators, which are those white boxes that are on the ceiling. Those one these locators are allowed to compute direction on a 3D space. So practically you can put azimuth and elevation. And in this particular scenario, by intercepting the directions that each locator can compute, then you can actually solve the 3D model.
And so what would be a practical application for this?
Well, you can do, so in this case, there would be location-based game. So think about role games, think about anything that you would like to engage with your friend by knowing where they are in a room. You can have like virtual obstacles that you need to go around. You can become a living pencil that you would just run around the room and draw a picture on the wall, things like that. And this is just related to games, but then think about retailer stores, shopping malls, airport, railway station. In there, practically, we can take the positioning indoor, and we can extend the journey of every user to the indoor. Currently, when you come to the front door of a building, well, you're kind of lost because you lose GPS, so you lose an accurate position system. This system can get accuracy to like 20 centimeter indoor, and the result is that we can now take you not just to the front door, but also combining the positioning with the maps, as I'm showing it there. Then we can actually generate routes that goes from outdoor to indoor. If you want to come to visit me at the office, you will practically put my name, and then you just generate a route inside the building to the escalator up to the 4th floor and then to my office. And as you walk inside the building, your phone will automatically switch between the different positioning technology that is supporting. So currently supports GPS, Cell ID, Wi-Fi, AGPS, like assisted GPS, and later on we support height as well. So the user doesn't need to click on the device. Everything will be done seamlessly. The map will change from outdoor to indoor. The positioning technology will be automatically chosen by the device, so that we will always use the one that has the lowest power consumption with the highest accuracy or quality of service requirement from the application that you're running on top. So let's give an example here. So this is about the games. So I have a copter, and then I put a tag on top of the copter. And then I have a 3D model there where we have an avatar helicopter. And what I can do now with my N9, I can practically just control the copter. So I can turn it on. And then simply by tilting the phone, I can just fly wherever I like. And as I fly the copter around, you see the 3D model there. I can actually show the real-time location of the copter.
So that's the helicopter flying within this space, and then you can see the system tracking it on X, Y, and Z axis. Pretty cool stuff. And so it's...
Frankly, the idea is that everyone can do the flying of the copter with the phone, but we are the only one doing the positioning as well. So then what you do, once you have an accurate positioning system, then now you're trying to combine all the ingredients together in order to extend your journey to the indoor. So when you go to a journey, then you need to combine positioning with maps and content. So that's what we are showing here. This is the model, the 3D model of Nokia World. This is an event which is run by Nokia every year. This year was in London. And this is about 20,000 square meter. And you see that everything here has some content with it. So everything is clickable, and whatever you click would, for instance, open a web page. So the idea is that I can create a 3D model of an indoor environment. And by the way, the 3D model here, it's based on what is called destination map, which is already a Nokia product. It was launched in CTIA this year in March. Those one are 2D maps of indoor venues. And in here, from the research side, we just build a 3D. The idea of destination map is that everything in this map, every polygon, has a latitude and longitude coordinates. So everything here is georeference, which means that I can take this map and really glue it on top of the outdoor map. Once you do that, now you can generate seamless routing between outdoor to indoor. Or you can go to like shopping mall. Look at this one. I can also have multiple levels, of course, multiple floors. And all these floors are connected together by what is called connection points. That could be escalator, elevator, staircases, whatever. And the route, of course, can go up and down. And that's pretty much the idea. So the idea is to create the ultimate seamless experience for the user and to allow them to really go to journeys without actually clicking anything, but everything will be done by the device.
Great. Thanks for your time.